Ooh, I'm putting an earth rod in the ground. Ooh, what temperature is it, honey? It's really cold.
5 degrees.
5 degrees. Wow, it's really cold. Oh. Right, but we need a good earth connection for this antenna. I'm going to prove whether this thing works or not. Hopefully there's no gas pipes in there. Alright, there we go. That's an earth rod in place. Alright, so what we're doing is, we're setting up a decent, well, we're setting up some kind of an earth. Nearly said it was a decent earth, but so what we're going to do is we're going to set up a long wire antenna, and that long wire can then be used to trap some radio signals, we hope, and charge the battery on this circuit. Please excuse us. It's really quite dark, so I've got my lighting system that I'm trying not to point at the camera. I've got this long bit of cable here, which I'm going to stretch across the garden. Well, hello again, people, and welcome back to the good old world of dubious engineering. So, here's the harvester project that we built the other day. Trevor from eBay sent me this, and there's the instructions. There's a circuit diagram here, and what we're going to do, just to cut a long story short, is we're going to take a battery, something like this one here. Let's just have a quick look at the voltage on that battery. Hopefully you can see that meter there. It's 0.9 of a volt, so it's way below where it should be. These batteries should be 1.2 volts. So we're going to take that battery, we're going to connect it up to the battery terminals on this piece of kit, and then what we're going to do is connect up the antenna that you just saw me putting together. Apologise if this is a little disjointed. Bit cold out here again this evening, so we're going to go ahead and connect up this antenna. This hopefully shouldn't take too long. I believe, looking at the circuit diagram, just trying to figure out, looking at the circuit diagram here, let's have a look at this together. So, without further ado, let's take this little pink wire, or was it orange? It was orange, wasn't it? Shove it into the BNC connector. And right, there it is. It's in the BNC connector. And then what we can do is we can put oh, I love people with loud exhausts. Loud exhausts are just awesome. Yes, I used to have a Harley, but no, kids with really loud exhausts. I think I must be getting old or something. Right, so hopefully you can see. Right, I need to zoom out, don't I? Right, okay, sorry. Right, okay, so there we go. So we've got 0.9 of a volt across this battery right now. We have got here, we have got another meter. This meter we're going to set to the microamp range, and we're going to put this meter, actually, we're going to put this across, the battery to see what kind of current. Wow, look at that. Actually, there does appear, I've got my polarity the wrong way around, but there does appear to be some kind of charge, 0.1 of a microamp, 0.01 microamps. Alright, well, let's just humour. Hang on, if I got this set up correctly. I believe so. Humour me. So, there you go. We'll put that meter in line. 0.1 microamps. And let's also just continue to look at the voltage across this. So there you go. 0.02 microamps. Now, the one thing that we haven't done is we haven't connected the earth. Let's connect the earth. And there we go. One radio earth. Yeah, okay. Oh, the radio's turned on. Let's turn the radio off. Yeah, that's quite important. Right, the radio is off. We're in the charge position. Doesn't really matter where the band is. No, okay. So apparently, if we leave this in place now, we've got a reasonable antenna set up. We've got a reasonable ground set up, as you saw earlier. Let's leave this in place and let's see what happens. But we do have 0.02 microamps of radio signal coming into this circuit, charging it. Sort of wish I had Trevor's telephone number. I'd give him a call right now and say, "Hey Trevor, is this what I should be doing?" To be fair, to be fair to him, there's an awful lot of instructions here. I probably should have read these. It does say a long external aerial can be connected via the BNC connector, isolated from the radio rail, used to harvest radio waves for power. In most cases, only an earth connection is required for the radio to function. Anyway, you know what? This is where we're at. 0.902 volts on a Fluke 77, so it's a reasonably good meter. This I don't really trust, to be honest. This is a test lab meter. I've had it for quite a few years. It is showing that we're drawing some current, so let's just see what happens. Alright, bear with us. I'm gonna have a glass of ale or something and we'll come back to this project. Okay, so the instructions say that an incoming RF signal is converted into DC and used to charge an external rechargeable battery connected to the battery terminals. Or you could use a supercapacitor. Anyway, the radio, now this is quite interesting. The radio is a TRF single transistor 2-band radio. What's quite cool about this is the transistor is a Darlington transistor, so it's actually 2 transistors in one package, and it does work really well. I'll show you that in a second. I have had a quick play with that, and the Darlington does work well. Here's the thing, look, we're now 0.903 volts. I wrote down the voltage earlier, 0.902, so it's definitely increasing. Another thing, I've also got with me a little handheld transmitter. So I'm just gonna, you can't see what I'm doing, but I'm putting this over to out the way of everything here on the board. I'm just gonna hit the transmit button, see what happens. There we go, power. The power goes up some, well the current, excuse me, increases a little bit here. You can see that goes from, sorry, I'm hitting the transmit button, you can't see what I'm doing, but 0.01, hit the transmit button, goes to 0.03. Yeah, so there's definitely something going on, admittedly extremely small something. Another sheet of paper here says that a long external aerial can be connected via the BNC connector, which is what I've done there. And that's isolated from the radio and is only used to harvest radio waves for power. In most cases, only an earth connection is required for the radio to function, but that's the radio, and we'll get onto that bit a little bit later. for right now, this all sort of looks like it's working. Even better news, Retro Man Cave came over the other day and very kindly donated some organic cider to the channel. So I must admit, I'm taking part. Thank you very much, RMC. And also thank you very much to Mrs. Dubious for videoing earlier this evening. Yeah, alright, so let's see what happens. Actually, this is another interesting thing, is it? Yeah, the harvester circuit, which is underneath these two cables here, is a set of germanium bridge rectifiers. So germanium diodes have a much lower drop across them as opposed to silicon diodes, so they're far more efficient. Let's see what happens over a period of time. Let's see if we get some let's see if we actually charge this battery up. It's definitely increased, which is good news. Not by very much, but it has increased. The voltage across the battery has increased. Let's see what happens. It is night time. I think perhaps during the day there's going to be a lot more activity going on the RF bands. So let's see what happens. Let's see if we get some power going into this battery. Okay, the currents and voltages that we're looking at here are very, very small. So my thinking is there's a potential for these meters to perhaps drain a very small amount of current away from the charge circuit. So I'm going to remove the meters from the circuit. So I'm going to get rid of the voltmeter here. I'm also going to get rid of the current meter, and we will let this work its magic overnight and see if that battery voltage increases. Let's see what it looks like tomorrow. Fingers crossed. Alright, we're a small glass of cider into this, and the missus, I'm sure, will moan at me very, very soon to say that we need to get some food on board. It's just 6:45 in the evening. Anyway, I've just had a quick email from Trevor on the phone. It says Poldo, which sounds like a Chinese name, is where Marconi did his first transatlantic transmissions. It's on the Lizard in Cornwall. That's the Lizard Point in Cornwall. He used so much power that people 5 miles away were getting sparks off metal buckets. So yeah, let's just have a quick look and see where we're at with voltage on this. Ooh, there was a 9.0. There was an early 9.04 on that, but it settled at 9.03. Yeah, it does look like it's actually doing what it says on the tin. Let's see. It's magic. Also, one thing to note: a friend of mine, Spungle Trumpet, who has his own YouTube channel, check him out. He says that we need to be a bit careful, that people do genuinely understand that when I'm putting this out as free power, it is very tongue-in-cheek free power, as in the very, very small amount of power that's going into this. Now, the other thing that I'm a little bit nervous about, the temperature this evening. At the moment it's about 5 degrees out here. Tomorrow the temperature is going to go up during the day. I don't know what kind of effect this is going to have on a nickel metal hydride cell. So this is a apparently 1500 milliamp hour nickel metal hydride cell at 1.2 volts. It is well undercharged. It should be, it should be 1.2 volts at a full charge. Anyway, blah 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 blah. Lots of talking and stuff, but see what happens. Alright, I felt the need for a happy ending, so here we have Sprouts, Marks and Spencer's solid milk chocolate sprouts and gold coins. Yeah, we're going to do an unboxing, unbagging and a taste test on those a bit later.